Good morning, everybody. We're just waiting another minute or so. We have a few people still moving in from the waiting room. All right. Well, good morning, everybody. Great to see you here for day two of our Stand Up for Grain Safety. My name is Barb Grove. I am your moderator today. I am the Quality Systems Manager with Central Valley Ag, Agriculture Cooperative um, in the Midwest. And I am a Jeeps member, one of our sponsors. And today's session, as you can see on your screen, is about bin facilities being designed for safety, so design flaws. Um, right now, we've got about 125 people on today, which is wonderful. So what to expect today? We have um, a few polls. We may have some group chats for you. We like to be interactive. So we want you to be able to join in with us, ask questions, and just in general, try to be engaged in this session. I do want to remind everybody that we do have a Spanish session this afternoon, a Spanish language this afternoon, and its topic will be Grain Safety 101. So if you have somebody that you feel that this would be beneficial for them, make sure to get them signed up. And we will have the registration link out there in the chat box. And you can register for one, or you can register for all the remaining sessions that we have this week. So as this week we are dedicating ourselves to safety, we want to remind everybody of what your rights and also responsibilities are. Employers are required to provide a safe and healthy workplace that's free of known hazards, even if you are not subject to OSHA enforcement. And as an employee, you have the right to a safe and healthy workplace, free of hazards, and you have to be able to report concerns without fear of retaliation. These learning sessions would not be out here and possible for you without the generous support of our sponsors and our partners. Those who help sponsor this week are ADM, Bartlett Grain Company, the Central State Center for Agriculture Safety and Health, Central Valley Ag, CL Consulting, Grain Elevator and Processing Society, or Jeeps, Grain and Feed Association of Illinois, the Grain Journal, Kansas State University, University of Illinois, Urbana-Champaign, University of Nebraska Medical Center, Lamar Advertising Company, and the National Grain and Feed Association. So let's get active out there. Let's show your appreciation by giving up that chat emoji for all these people that make these free learning sessions available to you. So at the end of our session today, well, thank you for all the love you're giving to our sponsors out there. At the end of the session today, we will put a link for you to download in the chat box for a certificate of attendance for today's session. And also, if you go out to the Stand Up for Grain Safety website, there will be a certificate of the overall event that you participated with us. And we really appreciate if you go out and do that one also, because that one we also ask you, how did you participate in the week? And also, what are some things that maybe you'd like to see. We want to take your feedback so that we can continue to put on successful events. So today's session will be recorded and it'll be available at a minimum in a few weeks. We've been getting them popped up there, out there on the Stand Up for Grain Safety website within about 24, 48 hours. So if you have somebody within your company that was not able to join live today, you will be able to still share this education session with them from out on our website. Okay, so at the end of today's session, when you exit the Zoom, there will be a short survey that'll pop up again in your browser, and we encourage you to finish that so that again we can get your thoughts for future sessions. So let's start participating by telling everybody where you are from. Where are you joining us from today? Oh, awesome. We've got some out of country members with us today. Thank you so much for joining in. And if you notice, a poll did pop up on your screen. Again, for us to determine how many people joined us. We know some people will share at their location and you all join as a group. So if you could go ahead and fill out that poll just to tell us how many people are with you, just to make sure you're counted. So while everybody's finishing telling us where you're from and also finishing that poll, I'm going to go ahead and introduce our speaker. So Carol Jones, Dr. Carol Jones is our speaker today. And Dr. Jones is the owner and engineer of
We just got muted.
Oh, all right, here we go. Dr. Jones is the owner engineer of CL Jones Consulting LLC, which provides grain handling and storage engineering training and forensic services. She's also the professor emeritus from Oklahoma State University in the Biosystems and Ag Engineering, joining OSU in 2002 after a career in production ag and materials handling design. Dr. Jones provides training and engineering information in grain handling, quality preservation, and safety. So I'd like everybody to welcome Carol.
Thank you. Thank you, Barb. And I really appreciate the opportunity to be here with you today. Anytime I get to visit with this many people all at one time about grain safety and keeping each other safe and our workers safe, it's just a really good day. So our topic today, as you can see, is the bin and facility design for safety. And please go to the next slide. I want us to think about, this entire week actually, but particularly our presentation this morning about the system that each of us works every day in the midst of. Especially when it comes to safety, we can't pull out just grain quality, just purchasing, just design, just management, just training. We can't pull out one piece of that and have the whole safety puzzle intact. Everything that goes on in your organization can be traced back or has tentacles in safety. Whether it's the decisions that management makes for purchasing new facilities, whether it's your engineer's idea about what to design next, whether it's a supervisor's choice of who he hires. Perhaps it's purchasing, making that purchase from our local farmers and the grain quality that they purchase. All of that has an impact on safety in your facility. So today we're going to talk about just the design and the equipment and some of the processes that are involved with that. So we're going to talk about one piece of the puzzle today, but please remember that none of this stands alone. It's all part of a system. So we're going to talk about, go to the next slide, please. Talk about why this makes a difference to us. And obviously, profit, that's our, I won't say it's our number one goal because safety is, but profit's right up there with it. If we don't make a profit, if we don't keep people safe, we don't make a profit. And if we don't make a profit, none of us come to work the next day. So we have to remember that we have just economic decisions to make also. But the safe working conditions are just paramount, and our industry is one of the most dangerous industries. Of course, I've seen you've got some pictures of fires there, but we have the engulfment and entrapment problem. We have high angle rescue type situations because we're working up on top of our bins and get into trouble up there. There's just so many things that can go wrong in our facilities that are very unique to this industry. So we will talk some about the design of our facilities that can help um, keep us from encountering some really catastrophic things, whether that's fire, explosion, loss of life, loss of property, engulfment, entrapment, bin collapse. All of this ties in together into one topic of designing our facilities so that they are profitable and that they're safe. Go to the next slide, please. We hear a lot about moldy grain because that is one of the major safety issues that we encounter, and it's a problem all over the country, but particularly where we have situations of fluctuation of temperature. I don't know about the rest of the Midwest this year, but we have had numerous days um, including today, where we start out at close to freezing and we're at 90 degrees, even in March, this early in the season. And those fluctuations of temperature is what causes condensation. Our facilities many times have leaks, things that maybe maintenance could help us with. But the condensation that comes down in on top of our grain or down the side walls or up in the headspace, from a design standpoint, is impacted by our management and design of aeration systems and the vent structure in the top of our bins. When we do have moldy issues, it's like the top left picture there, I can see all kinds of bad things about that. He's working without a harness, and there's these big clumps of grain that have fallen, stuck together grain are coming down. That's all a moisture issue that bin has encountered. The one in the top right picture there, those peaks all indicate a high angle of repose, if you're familiar with that term. When corn, that's corn. When it has a high angle of repose, that means that it's generally more moist than it should be. The angle of repose increases with moisture content. So we've got some moisture issues, and we're going to have to encourage that grain to come down because it will not fall down on its own. And they don't have a zero entry auger, sweep auger, so someone will probably go into that bin, and we all know that provides really dangerous problems. Picture in the bottom is the spontaneous combustion issue. As you can see from the quality of the grain around it that's not on fire, they had some moisture issues that we don't really know when that moisture problem happened. But we've got an extreme problem here, and grain, like any other biological product or even most particulate matter, will self-combust. And that's what has happened here. So go to the next picture. Next slide. As I just mentioned, we've got the self-combustion problem. It happens with moisture. Moisture leads to mold, and insects, particularly in the southern part of the United States or in a warm area, can actually set up housekeeping in our bins, usually in the top, in the middle, or around the access points unloading points, they will populate to such a point that they generate heat and it could actually cause combustion. So make sure you check your fumigation plans and stay on top of that. And we'll talk more about detecting this heat generation in a bit. Next slide. Get more into the design and maintenance of our facilities. We've got two pretty impactful pictures here. Anytime we have a sloped floor in a bin and we try to aerate that, that's some real challenges. You need to work closely with your aeration contractors to make sure that we've designed that aeration system down into that cone underneath our bins. This one, their aeration system didn't work, and they didn't think that would be a problem because they put some pretty dry grain in the bin. But as you can see, we had a problem. It actually self-combusted because they were not able to aerate. They had some moisture issues down in the bottom of this bin, probably from some high humidity in the unloading area underneath this bin. They did not have temperature cables that went down into the cone and they weren't able to detect it. So they found a big problem when they went to unload this bin. And over on the left, again, we see a self-combustion issue that happened down in the grain bulk. Um, I'm not real sure what caused this particular situation, but I do know they weren't monitoring temperature cables. It's one thing to have temperature cables, and that's a great design, and temperature cables are indeed your communication with your grain and storage. It tells you so much, even if you don't have a very intensive set of cables. Monitoring those cables, that's your conversation with your grain. That's when your grain can say, hey, I've got a problem, and if you listen to me now, we can resolve this. If you put it off, I'm going to have some big problems. So communicate with your grain using those temperature cables. If you don't have temperature cables, see what you can do to afford those and get them installed, because they will save you a lot of catastrophe in the long run. Okay, next slide. So how do we do all of this? Where do we start to look? And there's a lot of resources out on the web. All of your bin manufacturers have great educational resources. Of course, Jeeps, NGFA, most of your land grant universities have information out on the web, and it ranges anything from the quality of the grain to safety to bin design and management. So be sure and go out and look for some of that information. And most of us agree on just about all of the topics, so you can assure that you're getting good information. The American Society of Ag and Biosystems Engineers is another great opportunity for you to get information. Many times it's seen as an academic organization, which it is, but we have many, many manufacturers and industry people as members. It's in 2018, we gathered before 2018. It's just about a 4-year project. All of the bin manufacturers, the major bin manufacturers, some safety training experts, some universities, some of our larger bin companies and bin users, and some fire departments actually came together in a group to talk about what kind of standards we could put in place to make our grain bins safer. And so I'm not sure how many people were really aware of the outcome of this committee's work, but there's a standard with ASABE, it's S624, and send me a message, or you can go out to the ASAB site and search for that standard number. It is a standard for the safety design in steel bins. This is not a mandatory standard. There's no fines that are going to be written off this, and nobody's going to be inspected by this. It is a voluntary standard. However, if you have a bin tragedy in your facility, I would assure you this standard will be mentioned if there's any litigation. So make yourself aware of it. We'll go through some of the important parts here because it has some really good design information. This pertains to new bins. Now, There are many things that we're going to talk about that you can retrofit our thousands and thousands of old steel bins of all sizes that are still in the country. Our infrastructure is getting very aged. I think the oldest bin that I've worked in lately was 80 years old. So there are things that we need to do to those old bins that will bring it closer to this new bin standard, even though we can't do all of the things that are mentioned. These are all ideas on what you can do with your bin to make it much safer and keep our people safe and our grain in better condition. Next slide, please. The first thing we wanted to address in this standard was bin access. I'm sure all of you, if you've not had this happen at your facility or experienced it yourself, you've heard stories about access to the bins. Someone stepped out of the bin and missed the little 6-inch step that was not in the right place and fell backwards and hit their head, causing a concussion protocol. Maybe there's no way, no place to step when you step out or in or out of the side access. And so we put a ladder under it. That's probably not the best practice either, on the inside or the outside. Where our manholes or our access on the roof is located is a huge, huge issue. I would say 75% of our bins out there, the ones that I've seen anyway through the years, that manhole is probably 90 degrees around the side of where our ladders and our platforms are. Well, that exposes your worker to just a free fall environment there for a quarter of the way around our bin just to get in the hole. So when we put our bins up, if we can put those manholes closer to our ladders and actually have a platform underneath, that's a much safer situation when you try to work through that open access on the roof. So the standard has some designations on what the committee thought would be safer. The sidewall access at least 24 by 24 or 24 inches in diameter. And I can tell you years of discussion went into these sizes. Of course, the fire departments and the users wanted them bigger. The bin manufacturers had their limitations because of stiffeners and sheet sizes. So they came to the agreement that 24 by 24 was a minimum. No higher than 54 inches from the bin base for these side accesses. And if it's less than 24 inches, a step must be provided. And that step needs to be adequate for large feet. No personalities involved there for sure, but when you step down from the bin access, we tend to step back anyway. And if that step is tiny, it's really hard to hit it and not have an accident. If the bin access is greater than 24 inches from the bin base, we need to put a work platform with a handrail on it. Much safer than trying to step down 54 inches up in the air and make sure your toe ends up on a small step. Roof accesses, this was a huge, huge discussion item because we are very limited up on the roof how big those access can be because they have to lay between the stiffeners and the sheets. So 24 inches in diameter or 18 by 24 if it's an oblong opening. And then an external platform directly below the access opening. It works just like the access on the side where we're reaching down with our leg trying to find something to step on, and that's just a real dangerous situation. Internal ladders should be directly beneath the openings, and all of the ladders, cages, platforms, and walkways. There's another ASABE standard, S412, but that also reflects the information in the OSHA standards. So make sure that you're very aware of what those OSHA standards are. Every one of these items we could spend a whole week in discussion in classes. So I'm really hitting just the very high peaks of these, but I wanted to make you aware of what those standards are and where you can find them. And of course, all electrical equipment must be able to be locked out or tagged out. Um, I think any of us that work in the safety business will tell you if everyone locked out and tagged out, we'd be out of business. And I intend to work myself out of a job. Lockout, tag out takes longer. I realize that, but it's just the perfect way to keep a lot of our incidents from becoming catastrophes. So be sure that your equipment is able to be locked out and tagged out to begin with, and then that your personnel know that that is something that they have to do 100% of the time. Next slide, please. The next thing that I'd like to visit about in this standard is anchor points, this idea of attachment points. And that is something that, other than one manufacturer through the years, has not provided. There's no place to tie off to. If we wanted to, we couldn't because there's no place to tie off to in a steel bin. Sukup, I think, was one of the first bin companies that actually provided an eye bolt on their bins, and they were well ahead of their time. Long before this committee for the standard was developed, they were doing this. So we looked to them for some information. There needs to be two anchor attachment points, one near the peak of the bin and then one near the roof access. In other words, the manhole. The one up in the peak is for a pulley, a not passing pulley. And you can see there in the slide what the weight limitations need to be and how that was determined by our committee. A lot of discussion went into how much weight does this need to handle. And so the ultimate load of a minimum ultimate load of 2,000 pounds and a working load of 1,000 pounds. And these attachment points are meant for one person only. Why then do we design for 1,000 pounds? Well, many times we need to withstand an impact. Perhaps our person loses footing and drops a ways, or they break through a bridge and they take a pretty good fall. So those anchor points need to be able to withstand that impact. One thing to remember when you retrofit your bins for an attachment point, an anchor point, the anchor can handle 5,000 pounds, but if what you anchor it to will only handle 500 pounds, then your anchor point is good for 500 pounds. Okay, it's real important how we install and retrofit anchor points and what material we bolt them to. So many of the safety companies, safety equipment companies have retrofit anchor points available now. There are dozens of different designs and they all have their pluses and negatives. Again, we could do a whole session just on anchor point design, but all of your contractors will tell you it's only as good as what you mount them to. So give that some strong thought when you're retrofitting your anchor points. They also have anchor points for concrete bins now, and those are probably easier to mount and to work with and design than steel bins because you have more of a structure there to mount to. When we're mounting anchor points on a concrete bin, the weak point is in the bolting and how we anchor the bolts in the concrete. So make sure that you're aware of what process you're using to do that and get some advice on that if you're not clear about how to secure those into your concrete and that structure. Next slide. Safety decals. Of course, ANSI, ASABE, and a couple of other agencies, including OSHA, require different bin decals. These are the two that are the most often used and most often required. Make sure that those are readable. Make sure that they're bilingual. And unfortunately, I didn't pick a picture where they were, but make sure that you have your language barriers covered. Pictures are good because they bridge the language barriers. Our Global Harmonization Act really helps you with that. Go out and look for those pictures, but make sure that your decals are not so old and faded and cracked that they can't be read. So, do workers read them? Well, I hope so. Um, Sometimes we have to do the best we can and hope for the best, but they sure can't read them if they're not there. So be sure to have all your decals in place. Next slide. Talk about these fall prevention systems. The two anchor points near the roof and near the roof access are important, with the pulley being up in the roof peak with the not passing pulley. Um, The rest of that system includes a full body harness. This is not your lightweight working harness. We're talking good attachment points, padding around the legs. If you've ever had to hang from a harness for more than just a few minutes, you'll be the first one to go out and buy one of these harnesses that has the good padding around the legs. That's part of the safety issue also. We don't want to cut off the circulation uh, around our legs. Going to have a sufficient rope. If you've got, say, a 90-foot bin, your rope's going to have to be at least twice that. Okay. And of course, the anchor, we've already talked about the anchors. Now, an important part of this is not even a structural part, but it's an attendant at the opening. It is an OSHA requirement, and then just a really, really good idea to have someone working there at the access point of the bin. Their only job is to stay in contact with the person in the bin and to call 911 or alert someone if there's a problem. Their job is not to go get you water. It's not to go get your work clothes. It's not to hand you a flashlight. That's not their job, and they're not supposed to do that. Their job is to make sure that they're in contact with you some way. It doesn't have to be verbal. It can be line of sight. It can be by radio, but some kind of access and attachment communication with the person in the bin. So that's a piece. That's just as important a piece as the full body harness or the ropes or the pulleys. So make sure you work in pairs. Next slide. We'll switch from entrance safety to outside of our bins, and we've talked about electrical safety for all of our lives. I can't remember a time when we didn't talk about electrical safety. But I guarantee I could walk in any facility this very minute and find a problem. Electrical safety is just, it encompasses every single inch of our facilities, and it's an easy thing to overlook. Our older facilities, times have changed. Our regulations have changed. Our knowledge base has changed. What equipment is available to us has changed. So let's kind of look at some of these pictures because some of them are more intuitive than others about what the safety problem is. But of course, we start with the plug-in up there in the top left. It has a crack in that bottom receptacle. That needs to be fixed. If it's around any moisture, it needs to be a GFCI type plug-in. If we go down below, that looks pretty innocent until you see the opening in the side of that box. That's a safety hazard. This is a little side story that I'm not sure Oklahoma State University would like me to share, but they shared it, so I guess I can. About a week ago, we had a lizard get in electrical box on campus, and it shut down at least half the campus and our electricity. Of course, it blew the breaker and shut things down, so we didn't have a fire or a catastrophe. But it was because a lizard could get in one of these boxes. So make sure that your boxes are sealed tight. Also, from a dust standpoint, that's just essential. Look at the next one. Down there, the second from the left on the bottom. That has a hole in the side of a panel. That needs to be plugged. The middle picture on the bottom, we have a open breaker spot there. That's a safety problem. And our labeling is not complete. Every one of those breakers needs a good, readable, understandable label on it, even if it has nothing attached to it. It needs to say open or some indication that that breaker is not being used. Surely I don't have to explain the problems of the next to the bottom right one there, but you can see those particularly in farm installations. So hopefully nobody on this Zoom call would ever have anything that looks like this. Okay. If you do, go fix it. That's certainly a danger. And then a very common safety hazard is that box in the lower right corner. It's unlabeled. Otherwise, not a lot wrong with it, but it's unlabeled. You have no idea what that breaker box does. I'm sure there's someone in the facility that does, but if you have firemen that need to respond to your facility, if you have a new employee come to your facility, that's a useless box to them. Who knows what they're going to turn on and off when they go to use that box. Let's look at that light bulb up at the top. It's got a little cage around it. That's not a bad thing. There's glass on the inside. Um, it's a horizontal installation there. So we could improve that by putting a better enclosure on it, changing it to something besides the old-fashioned glass light bulb, and then hanging it vertically. We don't get as much dust collection when you hang it vertically instead of a horizontal surface. So make sure someone at your facility is, if they're not a code electrician, licensed electrician, they're very well aware of what these different safety hazards are and how they can be fixed. Because an electrical spark, we all have seen the news reports of explosions and electrical shock to workers. So it needs to be handled now. All right, next slide. Just a little more maintenance for electrical safety. Cords are notorious, particularly if they're outside. Um, make sure that your cord's insulation is in good repair. Um, I see in the chat here that some of you are offering good information. Hire a certified electrician to perform these repairs. Often repairs require entry into panels or equipment that will need to be de-energized and tested. Very good point. If you don't have a certified electrician on your staff, one of your personnel, then hire that done. That's the best way to know how to do it right, is hire the people who know. Okay, I don't, hopefully I don't have to explain that next picture to you, why that's an unsafe situation. And then the conveyor picture there with the red arrows going straight down. There's nothing, yeah, we've got wire nuts on it, and it looks like they've pretty well covered most of the wiring, but that's not a safe practice. So that needs to be into a box that is rated appropriately and enclosed. Again, we have a light fixture there with a glass bulb and nothing over the glass bulb, and it appears that there's liquid in there. I can't think of how unsafe that light fixture is. Hopefully, there's no energized wiring going into it. We can't tell from the picture, but I can think of about a dozen things that could go wrong with that, and I think all of you are well aware of that as well. So these are little things that creep up on us with time. So if you don't get anything else out of today's presentation, but an awareness that you need to be on guard and look for things as you go through your work day in and day out, and take a tour occasionally around your facility to actually look for some of these things and schedule them to be fixed sooner than later. Next slide. More maintenance that, of course, I've got some of the electrical pictures here, but this panel over here on the left, we've got things stored on top of a panel box. We've got things stored in front of it. It's dusty, it's dirty. Those are housekeeping issues. So make sure that you don't see that in your facility as well. Next slide. More housekeeping issues. The picture on the right uh, it would be very hard to access any of those control panels. And if there is some kind of a sparking issue, you've got a lot of paper products and equipment stored underneath. It's just a housekeeping issue. That material needs to be stored properly, and storage properly is not under the electrical boxes. Let's look at the tunnel here in the middle picture. That could be an electrical hazard, but that wasn't my point in putting it in the presentation. Obviously, they've had an unloading spout spill and it hasn't been cleaned up. This probably didn't happen just in one afternoon. So inspect your tunnels and keep them open and clear. This obviously could be an explosion hazard. It's certainly a worker hazard, a slip and fall hazard. It's going to back up into any rotating equipment in there and cause heat, and several things can happen when we have a hot spot in a facility like this. So housekeeping is part of design. Now, if you have a tunnel that is too small for someone to get in and clean, that's a design flaw. If you can't get to the bearings and to the downloading spouts there, and where it's easy to clean, that's a problem. It's going to get done a lot more often if your workers can walk through the tunnel unimpeded. So be sure and check that. If you're in a position, a lucky position of designing a brand new facility, I've seen some great examples of tunnel design now. That's something that our industry has improved over the years, and hopefully you'll keep that in mind. Labeling which bin that the download spout goes to is important as well, and that's something I don't see very often. But take some kind of a marker or spray paint to designate which unloading spout goes to which bin, because especially a new employee is not going to have the the knowledge and the feel for what bin they're under when they're down in the tunnel. So labeling is so important. The picture on the far left there is one I've used for a lot of presentations. That was caused by a leak in a manhole cover on a concrete house, and that clumped material goes 100 foot down the side of that bin. So checking to make sure that you have good seals on your manhole covers up exposed to the outside um, environment needs to be part of your maintenance procedures. Also, when you're building a new facility or you're replacing manhole covers, make sure that they fit well. That will help with keep your grain in better condition. Next slide. Just more terrible looking pictures here. The one on the left is obviously an explosion hazard. That's a rotating shaft in the middle there, and any kind of friction around that shaft is going to cause some heat. We got extra bolts laying there. Who knows where those came from? So that needs to be cleaned up and in the area inspected and repaired. And then another ugly tunnel picture. It needs to be cleaned up. We do have a shovel available. That's a good start. But we need to use that shovel. We need to get that cleaned up and figure out why that spill is there. It's one thing to clean up a mess, it's another to find out why the mess is there in the first place. That's when the real work starts and the real effectiveness starts. It's when you find out why you're having these kind of problems to begin with. So is it a controller problem and we didn't get something turned off at the right time? Do we have a leak in the conveyance system? Well, where's all this grain coming from? And how can we keep it from being there again? Okay, next slide. More ugly pictures. I have a stash, and John Lee and some other very helpful people have added to my stash of ugly pictures. But anytime you have rotating equipment, it needs to be free and clear with nothing but air around it. We just can't have the heat build up that kind of interference with material. Is a real problem for explosion. It's expensive because you have to put more electricity through this material and through this equipment in order to overcome the friction it's causing. So for a lot of reasons, that needs to be cleaned up. And again, find out why it looks the way it does, what caused the problem to begin with. Next slide. Let's talk about air vents. Sometimes we don't think about that being part of our design structure, but the air vents up on top of the vents, both powered and passive vents, are part of your aeration system. It's not a separate thing. They have to be sized to accommodate the air going in or out of your bin. Picture in the far right corner there, in the bottom right corner, that the top of that bin's not supposed to look like that. That had some vents that were iced over. Had a big snow ice problem. They were iced over. Someone turned on the positive pressure aeration system, and that popped in about 2 seconds. That was an expensive day. So make sure that you have adequate venting on top of your bins. And if you're building a new bin and you have the decision to make how many vents to put on top of your bin, add an extra one. Okay, more is better. This it's a little more expensive, but it's a whole lot cheaper than replacing a roof like this one on this bin. Also, if you don't have adequate vent spacing in the top of your bins, that's when you see your grain getting rained on. I had a person who had a brand new bin, really nice bin, call me and says, no matter what I do with my aeration system, it keeps raining down on my grain. Says that looks like a golf course in there. It's sprouted. I don't know what to do. I have tried every management I know how. So I went out to look at his bin, 250,000 bushel bin, and he had two vents up on top. So the answer is add more vents. Air goes in, it has to leave someplace. And if you don't have adequate the surface area in your vents is not adequate to handle the air that your aeration system is producing, then it's going to rain in your bin. So make sure that happens. Your power vents, power exhaust vents up on top of your bin, their their job is to exhaust the humidity out of your headspace. Their job is not to pull more air up through the grain bulk. They're not designed to do that. They're not the right kind of fan for that. That's your aeration system's issue. Uh, but those exhaust fans up on top of the roof, the power vents, can be a real help to you to keep the moisture and the condensation out of your headspace and keep some of that crusting and the bridges from forming and some of those golf courses that are growing in our bins from happening. They handle the humidity. Many of the power exhaust fans now are actually attached to a humidistat. So there's some nice design things about what's available for us. So I see in the comments here, air duct on floor of silos. Yeah, I'm not sure exactly what design you're talking about there, but the picture I had earlier with the duct work that went down in the cone underneath the bin, those need to be designed appropriately for the slope of the floor. They need to be inspected to make sure that they are not collapsed through the years of handling and that the perforations are open. Many times those get plugged up and then they don't do their job. So inspection and housekeeping is very important with those. And then the original design to make sure that the capacity of those the air ducts on the floor going down in a cone is very important. That needs to be a positive pressure system if you're going to use ductwork down there. If we pull air down into the V-shaped bottoms, you're going to cause yourself a lot of more problems than you want to deal with. So make sure that you're pushing air instead of pulling air through those. So I hope I addressed your question. If I did not, ask it again and we'll get a different answer. Go to the next slide, please. Let's talk about steel bins and bolts. Obviously, we all know that when there's a bolt hole that doesn't have a bolt in it, we have an access point into our bin and moisture can get in. But there's another uh, topic going on here. There's another phenomena going on here that we need to be well aware of. We've got several bolts missing out of one from one place, all in one place there. And as you can see, we've got grain that has spilled out, or it's actually glued to the sealing system, the foam tape that's between those two panels. That bin has shifted. Those panels have pulled apart, and in this case, it pulled apart enough that that's about an inch there. That bin's going to eventually be unstable. We need to find out why that bin shifted that much. Okay, it sheared those bolts, not because they were bad bolts, but because they have their limit on how much shear that those bolts can handle. So when you see missing bolts in a steel bin, make sure you decide or you find out why that bolt failed. It's one thing to replace it, which you definitely need to do from a moisture standpoint, but find out why it shifted enough to shear off the bolts. So maybe your foundation isn't exactly level. Maybe someone unloaded or loaded the bin not symmetrically. There's some kind of a force thing going on with those panels that pulled them apart like this. Bins always will expand and contract just with loading and unloading. That's a natural thing, and they're designed to do that. But there shouldn't be this much slippage between our panels that we shear bolts. Around the doors, let's talk about forces. And of course, obviously, this is an old bin, but stiffeners in a bin are their job is to handle the force and take the force down to the ground from our bins. So we have a stiffener or some kind of a support, and it comes down to the top of our door, and that force hits that, and it doesn't know where to go. There's nothing underneath it. So making sure that our doorways stay in excellent condition and they don't have a lot of wear and rust to them is so important because they have to handle that force coming down from that stiffener now. And of course, down in the bottom picture, obviously we've got some rust problems, some leakage from someplace, and that stiffener is not doing a job at all because it's not even attached to the ground. It's rusted through. So things that we need to consider and fix. Next slide, please. What do empty bins tell you? Well, underneath the floor, if you've got a perforated floor, it's going to be jam-packed with all kinds of fine material, maybe the insects. Your aeration's not going to make its way through all of that material and do its job. So find a way to clean underneath those floors if you can. Have to call a Millwright many times, but we need to check on that. Looking for discoloring on the walls. Let's go to the next slide, please. Is really important because that tells you a lot about what's going on inside your bin. Surface rust on the roof is probably environmental, and you may be close to a highway and it looks like that. The white rust on the outside on the walls, you need to go inside and see if there's anything on the back side of that. The red flaking rust is not your friend. That's the one that you really want to be aware of and find out where the moisture is coming from. The picture on the lower right is actually from part way up is from moldy grain. Above that, that could be from phosphine damage. Year after year after year of a lot of phosphine will actually deteriorate bin walls. Now, it's an extreme situation, obviously, but those are things that you need to be aware of, and what you can see from an empty bin tells you a lot about the management practices of your grain. Next slide. I think we're kind of winding down here with this, but cleanliness is so important. Maintenance is so important. Being aware of your facilities. This is an industry that never standardized on much of any kind of design. Every bin is different, and your people know that bin better than anyone. So ask them their opinions. What could we do to make this bin safer and sealed better, whatever the issue is you're trying to remedy. Ask them what their approach would be because they know the personality of that bin. We need to make sure we keep our explosion potential to a bare minimum, improve our aeration efficiencies. That helps with keeping our grain in good condition. It also keeps our energy use down, reduce the equipment wear and heat generation, improve your air quality. If we have a lot of dust, that is part of our dust triangle, our explosion triangle. So make sure we keep our dust down, and then reduce our bin failure potential just from maintenance of our structures. Next slide. Worker and management attitudes. Establish a CSA attitude. If you have employees that are working around those bins every day, they should feel like they can come to a manager and say, I see a problem. I think it's a problem. Look at it with me. Train them to look for the things that you need to be aware of. And then have your management commit to the time and dollars it's going to take for training and for replacing some of these situations before the catastrophe happens. We need to be proactive, not reactive. So, had another mention in the chat. If you're not watching the chat, there's a lot of good information on there. Replace bolts with the same strength bolts, not just bolts that fit. Very good point. And look for the quality of the bolt too. Some there may say that it's rated for a certain strength. Find out where it was manufactured. I'll just leave it with that. But make sure you use good equipment. So next slide. I think with that, Barb, I think if we've got time for questions, I'd certainly love to answer those, or else give them my email address. It's jcarroll@okstate.edu, or Barb can get us hooked up by telephone easily, and I'll be glad to work with you. I do site visits. I do a lot of, the worst part about my job is the forensic and legal work I get to do. I don't want, I'd rather fix the problem ahead of time than having to go to court over something.
Right. Well, that's exactly true. If hopefully, our wish for this entire week is that if people take the information that our wonderful presenters, our experts are giving us, we shouldn't have to see these things. We don't want to see these things. So thank you. Again, just a mass amount of information. Love the pictures because then again, we can relate. We see it and know what you're talking about there. Do have a few questions. One early on, and it was off of your first slide. Just a question about what is usually that sidewall radius hole, so your manhole entering from this side. Is there a standard?
24 inches.
Okay.
That, and I wish it was larger, and I think all of us do. The way manholes were first determined, the size that they are supposed to be, was way back in the early 1900s, and they were designed according to the tank standards. This is a wild story, but it's true. The tank standards, Army tank store, were the size so that an 18-year-old Army guy could get down in there. Okay. I don't know very many of our workers that are that size anymore, and I will include myself in that. But that's our grain facilities or the grain industry adopted that also, and that's where that size come from. Now it is dictated by our bin manufacturers and their sheets, their the stiffener widths and the width of their sheets. So we did get them all to agree. All of your bin manufacturers agree 24 by 24 at least.
Okay. Thank you. And I've got a few more questions, but I just want to let everybody know that Catherine is posting some certificates for today. So as we're doing the Q&A, make sure you go out there and you download that information. Again, you can recognize your participation and by going out to the Stand Up for Grain website. And there's a lot of great resources that are being posted right now in the chat. So make sure as we're doing the rest of this Q&A, you go ahead and copy and paste those into a Word document or email on your desktop so you don't miss out on those. A question, may stiffeners bear conveyor load? Or
That's
maybe it
not,
was to be many, but
oh, okay. If it's, okay. Well, the stiffeners, their job is to provide stiffness and structural force um, management for the bin itself. They are not designed, um, in most cases. Again, we didn't standardize on anything, but the stiffeners traditionally, 95% of them are designed to make sure the bin doesn't fall down. That's their job. And they are not designed to handle the catwalk. They're not designed to handle hanging extra things off of it. Their job is to
right.
make that bin stay where you put it.
Right. That's something to think about. Again, if people retrofit
All right.
temperature cables, or sometimes, again, when you talked about anchor points, a bin may not have been built, or you bought it more as, if you want to say, farm grade,
Right.
not commercial grade, and then retrofit it with safety equipment. That doesn't mean
It,
that roof load can
yeah.
handle that. So
It's
make
very
sure you
hard.
do that.
It's very hard to find an anchor point. I did some training with Detroit Fire Department years and years ago. I was a victim down inside of a bin, I mean, scenario, and their job was to pull me up out of that bin and set me over onto the pavement out of a large, fairly new steel bin. It took them an hour to find an anchor point to hook to. They ended up using their truck on the outside of the bin to anchor to because there just wasn't anything up there. The handrails are not strong enough. The catwalk may not be strong enough. The legs, the piping may not be strong enough. It's a tough situation. So it's something you want to think about now, not when you have the need for it. And
Right.
take you a spray paint can or something and identify that attachment point. But you can put all the equipment you want up there, but it's only as good as what it's mounted to.
Well, I think sometimes when we are looking at our capex or looking at the expense of a
Yeah.
project, um, sometimes we take away the grain quality,
Yeah.
take away fans or temp cables, or we maybe, I won't say we don't take away from the regulatory, but some of the extra safety things,
Right.
because it'll save us money. But realistically, if you think about the cost, you're going to at least triple your cost retrofitting it later, adding
Yeah.
things
Yeah.
later, and your bin may not be prepared for it. So, question kind of about temp cables and monitoring. How do we know our grain is losing quality in areas that we can't see?
That you will see a hot spot. I wish I had more of my pictures up here, but you will see a place down around the nodes in that location it, that are that are the temperature's going up. That's how do I say that? It's a hot spot there, and it'll be really warm in the center where the problem is, and then it'll get a little cooler as you go away from there. Anytime the temperature in your grain is more than the ambient temperature or the rest of the grain around it, that's a hot spot. And the sooner you catch that, the better you're going to have a chance of not having a problem there. Um, Turning the aeration system on will cool that down for a little bit, but it'll come right back because the problem is moisture. I guarantee it's moisture. And so the only way to really remedy that is to move your grain. Might be a good time to sell that bin or at least move it to another bin. But it's telling you I've got a problem here and it's doing it by the temperature going up. So make sure you monitor weekly. Until you get a pretty good handle on things. But when you see a spike, coming in there someplace. That's your grain saying, "Hey, I need some attention here."
Thank you. And then kind of in the area of your entry sweeps and sumps and things, what equipment can be installed to help unload grain that may have these clumps and stuck stuff?
Zero entry sweeps are a great investment. One of the best things our industry's come up with in lots of years. There are some other things that you can put over your sumps. I've heard sump weevil. I've heard of all kinds of different designs to go over the sumps in the bottom of the bin. Some of them have moving parts that break up the clumps. Some of them are arranged to where if everything's de-energized, someone could go in and work around there and get the clumps to go down into the sump. Um, there's a lot of things on the market, but to me, the best answer is probably the zero entry sweep. Best answer is keep your grain in good condition. But
Right.
we all know
Right.
that, especially on a wet year, wet corn year, that's not going to happen. So we have to know how to do that. We do have some equipment available now that some of the specialty companies can bring out to you if you know you've got a problem. We've got the equipment that burrows down in the grain. We have whips that can whip things and break inside the bin. There's a lot of different remedies, and but most facilities don't have those. You're going to have to call a salvage company or a company that does this kind of work. And Jeeps has a lot of those listed in their resources, so make sure that you have that resource available to you. But the zero entry sweeps, and then just know about it ahead of time before it gets into a bad situation with the clumping. Is going to be good. Many times you can break those clumps from down in the tunnel with a port through the spout underneath your bin and poking up in there. I do not suggest and would never suggest going into a bin with a rod and poking down into a sump. Um, Perhaps if everything's turned off and blocked off, that works well. But I have worked more than a few cases that it didn't work well and we lost people. So you're in there to make the grain flow, and so it's going to flow. Where do you think you're going to go?
Right. Well, so to that, Erica just asked the question. So, what if the tank's above you, and you're cleaning it from the bottom, never entering the tank? Do you need your CS permit on that?
It depends on the design of the tunnel. I've worked both situations. I've been in tunnels where it wasn't required to have a permit, it wasn't confined space permit required, and I've worked in tunnels where it very definitely was. So again, it goes back to the fact that I know this is not a good answer for you, but the answer is you need to inspect it and make that determination now, not when you need it. Decide now whether it's a confined space area or not. Um, it is a good plan to go underneath. If you've got to poke loose a spout, underneath is where you need to be, not in the bin. And they make ports that are the right size, and you can install those when the bin is empty, and then rod up through there and break clumping to some extent. But this confined space permit thing needs to be rectified long before you get to that point. All of your confined space areas in your structure should be labeled, and employees know they need to do that, and you have the permits available to fill out.
So, could you expand a little bit on the aeration management in the grain quality? And I did see, again, a question that kind of goes with that, or a comment from Jordan. It says, we run our fans for about 30 minutes. So this is about checking first. We run our fans about 30 minutes before going up on top to check quality if we don't have air cables. The heat and the smell at the manhole door will tell us. So that goes back to one
Yes.
of the other questions on quality.
We could do, and I would love to sometime, Barb, do a whole week on aeration management. That's probably one of my very favorite things to talk about. I teach a university class on that. But work with your aeration contractors to find out what system you need, size it appropriately, and then decide whether you want a controller on it or whether you're going to be the controller. The same thing's going to happen. You have to understand what's called equilibrium moisture content, which is what your grain tries to match the relative humidity and air that you're putting into it with the temperature that your grain is. And if you don't get that balance right, you can actually be adding moisture into your grain. Or you may be taking so much moisture out with your aeration system that you're costing yourself money because you're dropping your moisture content down too low. That's what your your control boxes are doing, is making that decision. That's all they have to do all day long and all night long, is sit there and watch that equilibrium moisture content chart and say, yep, we're going to turn the aeration on, or no, we're not. If you don't have controllers, and of course your temperature cables are all tied into this along with humidistats, you're going to have to make that decision when you have the time to go out there and turn the aeration system on and off. But there is a lot of information. If you'll contact me, I'll send you more information that you ever really wanted about aeration control systems and how to manage them.
Excellent. And Brad makes that comment, kind of what you're talking about. Again, looking at the relative humidity out
Right.
too, so that you aren't drawing. If you're, there's different aeration plan if you're in a humid tropical type
Oh, yeah.
environment versus, hey, how it's been this last year in the Midwest. Not a lot of humidity, dry winter. So it's very important to watch those factors. Also, a lot goes into it. There's
Yeah.
a lot of great systems. See, Catherine, put your email address
Thank you, Catherine.
out in there. So if people have some other questions, I'm just going to do one more question here before we end. Um, what are the important design points of sump guarding and machine guarding? Since you're talking about design flaws, what are some key
Okay.
points there?
Well, OSHA has a really good resource for us. Even if you're not under OSHA auspices, it's called Subpart O, and it tells us what guard, the bar width, and how far it is down to your rotating equipment, what that bar width has to be. And it varies from screen size up to about 2.5 inches. So I can't really say all guards need to be this design because, again, it varies with your structure. But the farther down that rotating equipment is, or your belt is, conveyor belt is from your sump opening, the bars can be wider if there's a breaking even point there. But if that equipment that you can be entangled in, or the auger or the belt is right up here close, where if you just got your toe in there, you get into it, that guard is going to have to be a very fine guard to keep people out of it. So subpart O, go to OSHA subpart O, and there is a whole guarding standard that is machine guards of all kinds, but there is a standard subpart O that applies to what our guards that go on top of these sumps have to look like.
Okay, excellent. Well, I appreciate everybody's activity out there
Thank
in
you.
the chat box for giving us your comments. Again, doing things like this, we are looking to learn from the collective knowledge of a whole lot of people. That's the
Absolutely.
Stand Up for Grain Safety event was about partnering, doing things together, sharing what we all have. So again, appreciate people being willing to share things for the rest of us to learn. Thank you for your questions. And again, I hope everybody has gotten a chance to copy and paste a lot of those extra items that have been out there in the chat. Thank you, Mark, for putting that subpart O out there.
Oh, thank you, Mark.
Boy, so people are really quick out there in helping us.
Yeah,
Thank you.
you guys are
Um,
amazing.
Thank
Thank
you,
you.
Carol. You give us such great information all the time. Really appreciate it. Appreciate working with you and your willingness to just be a great partner in this industry for
I'd
us.
rather do
Um,
this than represent you in court. So,
that's right. Everybody show a little love for Carol.
aw,
And
thank
again,
you.
make sure you're out there and registering for the rest of the sessions this week. This afternoon is a Spanish language session, not on this same topic, but on Grain Safety 101. Go out to standupforgrainsafety.org website if you haven't registered. Thank you again for attending, everybody, today. Have a safe and terrific Tuesday.
Stay safe.
Thank you, Carol.
Thank you for inviting me. I love doing this. So, thank you.
We love having you.
Let
Thank
me
you,
know.
Sahar.
Let me know what I can do if we have questions or whatever.
Okay, I put your presentation on a PDF and put it
Perfect.
in chat, and then your email. And Sahar, you can quit sharing the screen now.
Okay, thank you.
Thank
Good
you.
job, Sar.
Oh, thank you so much.
Thank you, everybody.
I'm glad that was helpful. So see you
You did a
all.
great job. Right on target.
Thank you so much. Yeah, I enjoyed your presentation.
Well, thank
Thanks.
you. Thank you.
Of course.
All right, let me know what you need, Catherine. Thank you very much.
Yes. Bye.
Bye. Bye, Barb.